You can unmute yourself and you can speak, actually. Uh, I don't think so. A lot of people will be messaging, so I don't think so. I will be able to see messages individually. Okay, so yeah, hello everyone. I'm starting. Just a minute, a few people are joining. So let's wait for a minute or two. This will be a doubt class. You can, if you want, I can also revise, like help you in revision as well, if you have any doubts regarding that. I will revisit a few things about the lectures of the last week, the assignments which we have completed, which you have like submitted, and if you have any doubts in those assignments, we can discuss them. I will also show some other things which might be useful in this course, as well as the applied part where this course will lead you to. Okay. So yeah, let's start. Okay. So hello everyone. Yeah, please keep muted for the time being. Let me introduce myself first. Then we can go on with your introductions as well. So myself, Sahil Mishra. I am doing PhD at IIT Delhi under Professor Tanmay Chakrabarty. I mostly work in natural language processing and graph neural networks. My core area of research is around developing taxonomies from text corporas, and also then applying those taxonomies for recommendation tasks. So I'm still admitting a few people, so let's wait. So that is the basic introduction about myself. Apart from that, uh, also work with large language models based taxonomy induction. So this is like just a second. A lot of people are joining. At any point, if my audio like cuts off, just let me know. Ping me here itself, or just ping me here. Okay, I will. So currently, I'm audible, right? I hope so. I've spoken a lot. Yeah. So the likes are coming up. So yes, I have given my introduction. Let's start one by one. Satyam Kumar, can you introduce yourself? What you are doing? What you are studying? Okay. 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 Great. Great. Uh, Next, Bhumika. Okay. Sorry. Please apologize. Like I apologize in advance if I mispronounce your names. So yeah, sorry, please. Sorry, your voice is breaking. Your voice is breaking. Yeah. We'll come back to you. Okay. Gungun. Hello. Okay. So, what branch are you from? Okay. Supriya Gupta. Hello. Oh, okay. We've got a lot of people from Cummings College, Pune. Okay. Bhuvna. Kurba. Sorry if I mispronounce your name. Okay. Pallavi, Pallavi Panhale. Okay, let's move. Yeah, please, Pallavi. Pallavi, please, yeah, continue. I don't think so. You're audible. Yeah, Aditya. Aditya H. Okay. Okay, okay. Got it. Anusha. Okay. Ashwin. Hello. Okay, great. Achay Achu. Akshay, am I audible? If you're not traveling or if it's possible, please introduce yourself. Okay, let's move on. Brinda. Okay. Uh, Dhruv. Hello. Okay. Okay, okay, okay. Great. Gautami. Okay, great. Kartikeya. Jan. Okay, great, great. Mahendra Prasad. Uh, hello, Mahendra. Okay, let's move ahead. Manas Thakur. Hello. Yes, yes. Great, great. Megha Kumari. Okay, let's move. Mohan. Are you there? Mohan is also not able to introduce. Okay. Nandika Murugesan. Hello. Yes, I can hear you. Okay, got Nandini. Hello. Priyanjali, Anjali, you're not audible. No problem. Let's go ahead. Padmavati, hello. Okay. Um, Purushottam, Purushottamman. Sorry if I mispronounce. Am I audible? Okay, okay, okay. So, yeah, if anybody wants to introduce themselves, please go ahead. I think there are a lot of people I cannot call everyone's name now. Like we have got almost 40 people here. Randomly, anyone, please. I just want to know like what backgrounds you all are from. Yes, yes, yes. Please go ahead. Great, sir. Okay. Ah, okay, okay. So yeah, thanks a lot. Actually, like we would also benefit a lot from your experience, your inputs as well. So I sincerely request you to please join every weekend. Yeah, please, just a second, please. Hello, Sriram, hello. Yes, Sriram. It's, I saw your post. Yeah, 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 yeah. Got it. Okay, awesome. I will certainly refer them to you just after the meeting. After this meeting ends, I will certainly interact with you all on. Just now, I got access to that discussion forum. So I was looking at emails only. So I will share. I will certainly share every the content, the material, everything with you all people. Okay. We got a lot of variety, experience. uh, Anyone else who wants to introduce themselves? It doesn't matter like if you're in first year, just introduce, please. Hmm. Okay. Great, great. Still a lot of people are joining. I don't know how many people can join on Google Meet. Yeah, yeah, Weber, please go ahead. Okay, great, great. So, how many of you are taking exam? Just asking. Great, great. Uh, you can put down your hands. A lot of clutter is on the dashboard. One, two, three, four, five, six. Great, great, great. Still people are joining. Got it, got it. Almost everyone is giving, I guess. Great. Shall we start or shall we wait? Like, I can see people are still joining. You guys suggest. You want to introduce yourself, you want to share something. Because when I'll start, I'll like I can also start sharing my experiences in graphs and machine learning. How do graphs interact? Exam date collide with MTech. Can we use this assignment and write till next? I am not sure, Sriram. You need to ask the NPTEL people. I'm just like coordinating with academic demands. I'm not sure about this time. Uh, you can like there's a help desk ID sort of something. I'm not sure. Yeah, there is. You can email them. Okay, okay. I will share it on Google Groups. Okay. Uh, for time being, okay, it is possible. Great. Okay, so I think we can start now. I have got introduction of most of the people, most of them from one college in Pune. Uh, mm, who's this? Shikha Malik, drug generation, PhD position. Great to meet you, Shikha, as well. So yeah, let's start. I Most of you might have missed my introduction because you people joined a bit late, and that happens first time. Plus, I would request all of you to please join sharp by 6 so that we don't waste our time on like there's a lot of things to discuss. Okay, you might have a lot of things to discuss, but to ask, I might have to discuss a lot of things about the course, not about just the course, about the content of the course, how the uh, things are progressing in assignments as well. So there might be scenarios where you will be facing difficulties. So we will discuss everything. We are open to everything. Apart from the management and this bureaucratic things like shifting of date of exam, and these all things I cannot handle. They're not possible from my end, but everything else, like, academic, we will discuss. Okay. I have iPad to discuss. Like I can write anything. There's no problem with that. So yeah, let's start. Hmm. So my name is Sahil Mishra. I am a second year PhD student. I'm doing PhD under Professor Tanmay Chakrabarti, and I'm also a PMIF scholar. So that's why we are taking this meeting every weekend, every Sunday, 6 to 8 p.m. Okay, that is our time slot, and that won't be changing. So I cannot change it. Like they have given this time slot to me, so that is the only possible time slot for me as well. In like the best in like 99.99% chance there won't be any change, there won't be any cancellation. We will be attending it every weekend. Okay, we will be discussing the assignments from the past week, and we will also be discussing some of the questions related to assignments. Okay, so this is the basic thing. Apart from that, my PhD, which whatever I'm doing, is also in graphs as well, in taxonomy, induction, generation, and completion. So a bit of that, a bit of this course has helped me in my PhD. It will help you all as well in your jobs, in your whatever uh, venture you are pursuing. Okay, it is like an open-ended interdisciplinary course. Later part, there will be mathematics, there will be technicalities involved, and if you are not able to understand, then we are here every weekend. We are here to discuss that as well. So yeah, let's start. First of all, uh, you all might have submitted the last week's assignments, okay? Last week assignment one. And I think that was pretty easy. Still, I will go through it. I will discuss the assignment in detail, as well as I will discuss some other things. Yeah, the link will be same. I think you might have got this link on NPTEL forum. So the link will be same. Don't worry about that. That won't be changing. If anything happens, I will inform in Google groups, and there are a lot of channels as well. So I will inform beforehand, but that won't happen. There will be this whole system, this whole it is robust, and we won't be changing that. So let me share my screen, and first of all, let me open the assignment. Week one. Okay. Hmm. I'm sharing my screen. Is it visible? Just like or something, whatever pops from this side of my screen. Great, great. Uh, we are having the attendance, current attendance is 55. Okay, so yeah, let's start. Okay, people are still joining. I sincerely request you, like, please join by 6, 5 max. Otherwise, we will be delaying this stuff. Okay. So yeah, this is the assignment for week one, and someone is here. First of all, these are like three, four lectures. This is a very basic lecture in which we discuss what is social network analysis and what is the need to study social network analysis, first of all. There's a lot of use cases of social networks as we've discussed so far. And there are like types of networks are there. There's in the online we have Facebook friend circle network. Then we have your Twitter network. You have your publication versus citation network. There's a lot of networks out there, and applications also. These applications they are pretty basic, and from basic I don't mean to say like these are basic applications, but they are applied everywhere. So social networks are everywhere. Whatever, if you are involved socially, you will be involved in some of the networks. So that is the basic gist. What is a social network, and why do we need to analyze it? Because uh, we cannot simply process what happened. My screen gone. Okay. We cannot simply process the network information. The computers cannot process it, and that's why we need to analyze it. We need to come up with some methods to analyze it so that we have some quantitative analysis of the network. Okay, we cannot just say you are friend with these peoples, and these people have some preferences, that's why you are having some preferences similar to them. That is a qualitative analysis, but we need to analyze some quantitative properties as well. That's why we are studying these things. Okay, this is all about lecture one. Coming to lecture 2, these are the preliminaries of the social network. Wait just a second. We have got 59 participants. These preliminaries you might have studied. They include what is a social network, what is a node, what is an edge. So these are basic components of a network, which we have described here. We have discussed. Coming to lecture 3, this tells about the historical development of social network analysis, how it has happened in the past, and how it will keep on maturing in future. Okay. So first of all, let's discuss week 1 assignment. Okay. This week 1 assignment had 10 questions, 10 marks, very simple. Uh, Before I discuss the answers, I will simply speak the question, and I want you people to write in chat if you have any doubt in this question, and then I will discuss the doubts. Otherwise, we will move to I will directly discuss the solution of the question. Okay. So social network analysis cannot be used in healthcare domain. For example, to map susceptible people from infected ones. Don't post. Okay, okay. Deadline is not over. So we cannot discuss answers. Please don't discuss answers. Sorry, guys. No, no, no. Then I cannot discuss a solution. I thought the deadline was over by yesterday. Sorry. I will just discuss it. What I will discuss the question. Okay, and then I will discuss how 7th August is deadline. Okay, okay, okay. Great. Okay. Wait. Don't type. Okay. So I will just speak about a bit. I'll just tell the context about the question and how this question can be solved easily, and how you can come up with a say solution of yourself. So, can social network be used in healthcare domain? We have seen these applications of network here, the historical development. So, healthcare domain, what are the possible applications of social networks in healthcare domain? Hmm? One basic thing which comes to our mind is connecting hospitals to people. Okay, say how will you connect the hospitals to people? You can create an app where hospitals can join, where people can join, and ultimately we can create a uh, a basic network where hospitals and people are connected. This is one basic application of social network in healthcare domain. Now, what happens? A person is taken to the hospital. Okay, then we get to know the hospital does not have proper facilities to treat the person. Uh, how the hospital will know that this facility is available in another hospital? For that, we can also create a social network of hospitals where we can share the information about their functionalities, their uh, capabilities, what facilities they have, everything. Okay, so that is one network, uh, hospital versus hospitals network, and the other is people versus hospital network. So you might have seen that people are one type of entity and hospitals are another type of entities. Okay, now kindly think that people cannot be connected to people. People can only be connected to hospitals. Hospitals can be connected to people. So we have a graph where we have two types of entities and they are joined like this. Okay, this is one type of graph possible in healthcare domain. The other possible graph is all hospitals are connected. That is a complete graph. Okay, what is a complete graph? Anybody type in this thing. You want to speak, you can speak. Okay, just like it should not create a lot of chaos here. Can I ask randomly from anyone? Correct. So we expect that all nodes are connected because all hospitals need to be connected so that we know if this functionality, this facility is available there. Okay. Then we have another type of network where, say, pharmacies are connected to hospitals. Okay. This one possibility. Then pharmacies can be interconnected as well. So there are a lot of varieties possible. Now coming to another possibility, another case. Okay. Say there is an outbreak of dengue in a region. Okay. So a person gets infected, and in his house, every person is susceptible to get infected. But does that mean they belong to a network or not? They can belong to that, depending upon whether they will get infected in future or not. So these type of graphs, as you see now in Facebook, is there, they are growing graphs. But it's the growing graphs are those graphs which grow slowly in future over time. So there are algorithms uh, which predict the growth of the graphs. There are things we will discuss in later parts of the course. But first of all, let's think of this thing. Are those people which are living in the house, are they susceptible or not? Tell me some like will they be the susceptible people? Will they be the part of the graph which the person has started forming? Because say a mosquito is here, okay? The mosquito, it bit one person, then it bit another person. So you have fallen into the graph of that mosquito. But there might be a scenario, there's another mosquito coming up. That is biting you, that is susceptible to bite the people in your vicinity. Uh, don't get offended by when I'm saying you, okay? Mohan is sharing your screen. Don't share your screen, please. So, yeah. So this type of graph is also possible where the nodes are connected and they are connected via source as well. So there is a connection which is connecting you apart from your direct connections. Okay, we all like these type of graphs are common, and that is why we need social network analysis. We need to discuss these all stuff here. How, like, what to classify, basically to classify what type of graph this whole system is forming. What type of graph will it evolve into? These are the basics, and these basics are used in research a lot. Okay, especially the research which involves this infectious diseases research. Okay, these type of graphs are used a lot. This type of graphical analysis. So yeah, since we cannot discuss the solutions of the assignment of this week, I'm postponed. Like, it's better we discuss the solutions. We discuss these assignments next week. Okay, by next week, I guess the deadline will be over. Hopeful. Let me check. No, it won't be over. Shit. Okay, chalo, no problem. I can discuss this thing, okay? I can discuss the tutorial part here first of all. 7th August. Okay, okay, no problem. You can keep it backdated to something like that. For time being, I can discuss your doubts about course, about anything, and this Python collab, Python that's network X, these things. Okay, because I know most of the people are BTech first year, BTech second year who are not very good at programming graphs, and especially they are not flexible with using these libraries like network X and these things. So we can discuss this, and we can also discuss your doubts as well. Okay. So no. There's no need to purchase premium collab. Nothing. You don't need even GPUs. Like in later parts of the course, when we will be studying graph machine learning, then also we'll be dealing with small graphs. Like I do graph machine learning codes on my laptop without GPU. It's not like very huge graph. Very small graphs are there. whenever I need GPUs, whenever I need to generate embeddings representations from large language models or language models, then only I need GPUs, huge GPUs like 40 GB, 60 GB. Otherwise, there's no need to purchase this Colab Premium. Okay, the basic service works. Apart from that, there's Kaggle. There's no need to learn Python geometric for now. Uh, uh, Anyways, it is easy to learn Python geometric. I will share some tutorials. I will discuss those tutorials here as well if you people want to attend it. Otherwise, I don't think so. It falls in the scope of like most people won't be doing it. So we will not be discussing it in depth, but it's very easy, first of all. Secondly, it will come in later part of the course, like after week 8, 9, 10, like that. It is uh, in advanced part where we use graph machine learning. So yeah, it will be helpful later. Like Sriram, you are like PhD, you need it, but most of the people here they are BTech first year, and I will teach it. But first of all, I will teach these basic stuff. This basic stuff involves network X. Okay, first of all, we will study network X. Uh, Local laptop. You can use a local laptop. What it matters is like how much RAM you got to install Jupyter. I don't think so. These graph modules they need a RAM more than 8 GB or something. If you have got 8 GB RAM, it is more than sufficient. Sorry, GPU. 4 GB GPU is sufficient, 8 GB RAM is sufficient. If you have GPU, otherwise it doesn't matter. You can run it on RAM, CPU as well. We will discuss Python geometric, but before that, we will discuss network X first of all. Okay. So what I will suggest is I will open a collab. See, you guys check if you guys can open collab and whatever I'm right. Hello, Oduri, Priyanjali. Do you have any question? Hello. Okay, okay. I'm trying to implement on a different analysis text, bipartite, how to approach, how to analyze this data set. I will come to that as well, Kartike. First of all, let me start with basics. Okay, you have knowledge about sentiment analysis, you have knowledge about text data, but most of the people they are studying it for graphs. First, we will go slowly there. Hmm? We will discuss your doubts. So first of all, uh, can you guys open Colab notebook? Any empty notebook, please open it. If you have any problem in opening this, type collab.research.google.com or search in Google, Google Colab. Okay. I'm waiting for 5-10 seconds. If anyone has problem opening it, please let me know. Great, Vaibhav. Mhm. So once you open the notebook, research opportunities at Triple IT Delhi. Uh, this IIT Delhi or Triple IT Delhi? I'm not affiliated to Triple IT Delhi. I cannot tell. Tanmay sir has moved to IIT Delhi now. He is not at Triple IT Delhi, so I cannot comment on that. Okay, so that's you can discuss these stuff on this Google Groups. This is the thing here. Yeah, we can discuss this here. Still, people are joining. Okay, so once you open Colab, you will see something like this. I will go through its each and every component. Okay, so I suggest you guys watch it carefully. Who don't know anything, those who know like they can watch it. Otherwise, they can just see anything might come up. Okay, so first of all, this is your Google Colab. Google Colab is basically an interpreter for Python. If I type anything in Python, it is running. Okay. So interpreter means I don't have to run the code from start. I can run it, a small job, a small part of the code. That is the purpose of interpreter. Now, what each this function, what is the function of this whole thing? Okay. If you click on plus code, it will add a new editor here. If you add text, it will add a text box here. That is not executable. Means if you write code in this text box, it won't be executed. Then we have here, uh, let me refresh it. Let me reconnect it again. So I can show you how the memory and other stuff can be managed. Okay. So it needs to connect to some backend machine. On that you run the code. Okay. So this is connected to a host already, which has 12 GB of RAM and disk space of 107 GB. I have not subscribed to anything, so I don't need like because I don't need any other resources. This is sufficient for me. I can change runtime type from CPU to GPU. Okay, 800 is purchasable, so they have switched it off. It's not free. Then this L4 is not free. These TPUs are free. This GPU is free. I can use Python. I can use R as well. So the coding thing I will be teaching in Python only. I won't be teaching in R because first of all I don't know R. I'm not proficient in R, and also the assignments and everything, the coding assignment, coding everything is sufficient. Python 3 is self-sufficient. Okay. So those who want GPU, okay, you can simply change runtime type. You can use this default GPU, and this helps connecting it to GPU. What the what is the purpose of GPU? So GPU basically makes the computations faster. Whatever deep learning stuff, whatever machine learning stuff we will do in later part of the course, not right now. Those things will require this GPU. A bit of it, but that is fine. Okay, now we see resources here. So I have system RAM 12 GB, GPU RAM 15 GB. 15 GB is a lot for this course. It's a lot, and we have disk space of 78 GB. I don't know why it reduced. So yeah, these are the resources which are available to us. Then we have this file option where we can open any notebook. If you have a notebook on local server, you can upload it from here. Okay, you can upload it even if you have something on GitHub. Say you have a Jupyter notebook on GitHub. So I hope you all are familiar with Jupyter notebook. Who is not familiar with Jupyter notebook? Please message here. Most of you are familiar, great. So you can connect GitHub from here, you can upload, you can even connect to Google Drive or to Open Notebook here. Okay. So this is your Google Drive, you will find a lot of stuff here. Then these are edit options will basically allow you to select and move these cells. If I press Control X, they are gone. If I press Control V, they are here again. Okay. So this is the stuff which these things can do. Then this insert option adds code and text, everything is there. This is very important, this runtime. You should know this because say you want to restart your code and you don't want to basically refresh it. So what you can do is you can just come here, you can restart the session and your variables will be lost. Okay. And you can also interrupt this execution. Say if I start a for loop, I'm writing this way, for loop which is infinite. So it will keep on running, it will hang the system, it will consume all the memory, everything. So you can just basically interrupt it from here if you want to interrupt the execution in between. If you don't want the code to run, You can change runtime type as well from here. Okay. You can manage sessions, your active sessions. If you have like two, three notebooks running here, you can kill it because if you're running two, three notebooks, you won't be able to use GPU on all of them. So that's why you might need to close the sessions. You can view resources here. Okay. There's a runtime log. Runtime log basically tells the how your notebook is running. So your kernel was interrupted. See, I interrupted your kernel here. Interrupted the kernel here. I restarted it. I started it. This is the host ID from on which this kernel is running. Okay, this is beyond the scope of the syllabus. So I'm just showing you what things you can see. If I run something, so will it come in the logs? Let's check. It's not coming. So yeah, just it is not coming. Okay, no problem. So yeah, that's all. That is the basic of Jupyter Notebook or Google Colab. If you guys want me to teach you some of the basic stuff of coding, how to do, not familiar, okay, you're not familiar with Jupyter Notebook, okay, I would suggest like just pause this. Thanu, I would share a YouTube video to make you understand that will teach how this Jupyter Notebook stuff works because it is a very time-taking, time-consuming thing. And if you have a PC with say 4 GB of RAM or 8 GB of RAM, please install it on your system. That will help you. That will help you in understanding like how to code in Jupyter Notebook, if that is possible. Otherwise, if it's not possible at all, you can start using Colab directly. Like I don't recommend installing it because it is just a waste of time to install Jupyter Notebook here when you have Colab here. If you're having resources which are a lot, say you have more than 15 GB of RAM on your system, you have more than GPU on your system, you have more than 12 GB of RAM on your system, then you can prefer using your system. Otherwise, I would suggest use Colab. It is very simple. So what you can do is you can start using basic Python programming knowledge, your programming knowledge here. Say you want to add two numbers, a plus b, which is 5 plus 8. Simple. It's giving answer. It's interpreter. It's doing its job. Okay. So this is how it will work. And this is, people are still joining. So yeah, this is how it works. And you can do discrete modules. Discrete modules means these codes, the first code and second code, they need not be linked together. And you can also do programming in flow. So you can do one operation here, say A is set 5, B is 8, then you can do A plus B. Okay, so like that. This is basic, very basic. I don't think so. We need to study these things. Okay, this is the basic of Collab or Google Colab here. Got it? If anybody has any doubts, great, great. If anybody has any doubts, please message here. No doubts? Great, awesome. So next part is, I don't think so. Like this Jupyter notebook is telling how to read data. Instead of instead of going through these operations, how to read data, how to write data, I will show you how you can find these things on Google itself. You don't have to worry about how to read data, how to write data, and you don't have to basically go through this video to understand, to complete assignments, to do anything related to graph. I will show you here itself. Okay, how can you how you can do these things without even going through tutorial videos and stuff. Since the advent of this chat GPT, people have started using that to get codes. But before that, Stack Overflow used to be there. And I still like it, Stack Overflow, because If you start searching for something and if you don't find that thing, you still learn a lot of things there. So I will show you that. Okay. So people are still joining. Before we go to network X, mhm, I will show you how you can upload a file. Okay, how you can upload a file on Google Colab, how you can connect your directory, Google Drive directory, to Google Colab if you have some data there. Okay, so say I download a sample text file. Okay, I will get a sample text file here. I will download this file, download it. So what I can do is, these are the things, these are operations. These things are very important in Google Colab. You can manage the flow of your notebook by writing beautiful executable scripts here. Anybody can read what is written here. Okay, I will show you. I will show you. I will show everything. Okay, so new section. What we can do is, I will show you from start. I've deleted everything. I will add a section. This section can be directly added from using this text. Okay, so read a text file. Enter. Sorry, one more thing. So you have written say 5 plus 8. If you press enter, it will keep on going there, there, there. It won't run. So what you have to do is you have to press shift enter together. Shift plus enter to do this thing. Okay? Or you can just click here. So I've written this read a text file. This is markdown language. So markdown language, I can make it bold by using double star. Or I can change the size as well by pressing this by see. If I write single hashtag, it's very big. So if I write single hashtag, it becomes a section here. If I write double hashtag, it is still a section. It will become subsection ultimately. So this is the basic. This is the basic here. Okay. So now, yeah, we have downloaded the file. Let's upload it. How can we upload it? This is very good. You can use it search and replace. So we have come here in this left side, this fourth one, two, three, four, five. This fifth last one. You can click upload file and this file has been uploaded. Okay. So no, okay, I don't know how to read a text file. Okay, how I don't know. You guys know very good, but I don't know. But I will see how to read a text file. Okay, so I will search how to read a txt file in Python. Okay, best solution you can find these basic problems. These the solutions already exist on Geeks for Geeks, and this will help you a lot. You go through this stuff. Okay, I won't be able to teach all these things, but I suggest you go through this stuff. I'm making you understand how you can search for a solution to a problem instead of just giving you a solution to that. So yeah, see, what it's showing is still people are joining. Python provides built-in functions for creating, writing, and reading files. Okay, so we do not have to import anything to read this file. Two types of files can be handled in Python. Normal text files, we have txt file, that is text file, and binary files. Binary files we will discuss later on. For now, just say we have to read text files, okay? So file can be read and written. So there are file modes. This is a read-only mode. You only read the file. You want to read plus write the file. You want to just write to a file. You want to write and then read. Okay. There's an append mode, which means you have to you have already existing file and you want to add contents to it without erasing the previous contents. And then there's append plus read operation. Okay. So what operation do we need here? We want to read the file. We will just use this R operation, this access mode. if you study how the files are loaded in memory, these are file handlers, other stuff. But okay, let's move on to the code. We have this file. We use this built-in function open to open the file in read mode. Okay. Mhm. Okay. So say he has read something here. Let me copy it. Let me show you directly. I will read this sample.txt file, but I don't know where this file exists. Okay. So I will click here. I will copy its path. I will paste its path here. So it is in content slash sample3. I'm opening it in read mode. The output of read function is file1 dot read print. So this is the file, okay? And if I open this file, this will be the same. This is a sample lorem ipsum file. These are present online. So you have read this file in this file dot read operation. But how do we use this stuff? How do we use this data in our code? We cannot just read this file and say that yeah, the file is in memory. We can directly use it. So we have to save it to some variable. Okay. So say I create a variable name file underscore data, which is equals to file1 dot read. This is the content of this file. I'm reading it directly in a variable. Now if I print this variable, nothing is coming. Why? Let's go here. Yeah, so you can see, just read will give you the first line. I want to read everything. I want to read everything. So this read is giving an empty thing because it is giving me a pointer to the start of the file. This is the basic operation of file, okay? So if I want to read everything, let's go to read lines. This is empty. Just a second, let me reread it again. Yeah, and if I print this should also work. It is not working. Okay, uh, just a second. Okay, great. So what happens is, in order to read a file, you need to what you can see. This thing came up. These issues came up because I was trying to read this whole stuff, this file in multiple steps differently. If I read this here, if I press this operation here, okay, it is printing me. It is printing the data. But now if I do this, see, empty. Because the file has already been read. This pointer has, the pointer which reads the file has already moved to an end. That's why it is empty. So we need to open the file again, read the file again, print the file again. So we have seen two methods to read. One is file.read, other is file.read lines. Okay, so I will show you the difference. File data lines. In order to just get rid of this discrepancy here, I'm moving it in one cell. Okay, so in that way, a file will open again if I want to read it. See, this file data is here. Great. And if I print this, very basic difference. What you can see here and here. Please write in message what is the difference in these two things. Whosoever knows, please write it. What is the difference between these two read operations here? You might think that this is a waste of time going through this stuff, but most of the network, like the graph files, are edge lists. So whenever we have a graph, the basic graph files which are available online, the graph data, it is in the form of edge list. A A and B, there is an edge. So A comma B will be given, then B comma C will be given. It will be a TXT file only. Okay, so you have to understand why we are studying this, because later in the course we will be reading files. We will not be just reading binary files. We will be reading TXT files. Yes, Shikha. Read gives us string output, and read lines gives us strings based on each new line. Great. So you can see this file data. This file data, it looks like a text, but this one looks like a list. Let's check the data type. Okay. So what is the data type of file data? File data is string. String means start to end. Everything is in one quotation string. Okay. So this read makes it difficult to separate uh, lines individually. Okay. How does it affect the code? How does it affect our job? When we have edge lists, though, so this is the edge list, this is the edge list, this is the edge list, this is the edge list. This is an edge, this is an edge. So we won't be able to separate them. So that's why, see, if I print this thing here, so what is the type of this file? It is a list. So whenever we do read lines, we will be basically splitting this string on new character, new line character. This is the new line character here. This character, after it terminates to the new line, we will be splitting it. So you can see the code, epidm, non, rendo, whatever it is. Then there's semicolon, there's backslash n. Backslash n is there. We come to next line. So it is splitting on next line character, and it is putting this in different elements of list. Okay. So if I print 0, you will get this thing. If I print 1, this is the second. So you can get the edges directly in the form of list. So that is why whenever we read this stuff, this edge list file on our in code, we always prefer this read lines function. We don't go over for read. You can do read, but it is very complicated to first read a string, then split it, but perform parsing. I can simply run a loop over that. Okay. So uh, for an edge in this file, print edge. You can directly get all the edges like this. Okay. So that is why read lines helps a lot whenever we are coding. Secondly, when we will use network X, okay. Now in 5 minutes I will start networks as well. Whenever we will use network X, it helps a lot when we have edge list. Directly we can create a graph. And say you don't know network X. Uh, Consider I also don't know network X. So how can we utilize the documentation present online to learn more about it? Okay, I will show that as well. This is very basic stuff, but still I'm showing you because this thing I'm writing here, I will share this notebook in on this. It's possible here. If not, I'll share it. Everything will be shared. Okay. So I will share this notebook with proper text, proper documentation. Everything you will get to know. So this network X, what it does, this edge list will help in using the directly importing the graph in network X. That's for later part of today's discussion. Okay, so till now, any doubts? Anything? Like very small doubt, any silly doubt, anything, whatever you want to ask, you can. Just type it here. You can raise hand if you want to ask on mic, like you want to unmute yourself and ask. Hello, everyone. Am I audible at all? You guys are just listening blank. Yeah, cool. So, okay, so no doubts. Great. So, yeah, this is the basic. This is the basic. And why did I show you? Because we will be using, who's joining now? Okay, so we will be using this stuff when we will be using network X. Okay, great. So let's start using network X. Let me check if it's installed or not. So I will import network X. It is installed. Great. You can also use aliases here. Aliases help you in creating short names for libraries if you want to use it. Okay, so I have created this graph. So imported this library, sorry. So let us create a graph, okay? What graph you want to create? Let us create a linear graph. What is a linear graph? It's a path from node A to some node K. We have nodes connected in sequential line such that there are no connections which make triangular loops or full path, something like that. Okay, you're getting the point. So consider, I cannot write in this because it is a code section, so I will create a text block here. Consider we have five nodes A, B, C, D, E. They are connected in line. Let's define it. How can we connect nodes in line in Python? Any ideas? How can we create how like much like you can create in your mind A to B, B to C, C to D, but Python won't be understanding like coding these languages won't be understanding it. So how do we connect them? Okay, first leave that. First of all, how do we define them? Nodes is equal to A, B, C, D, E. Nodes are defined. How do we connect them? How do we create edges? Anyone? Dictionary? Okay, yeah, dictionary is possible. Dictionary is possible. Dictionary is very good, in fact. Some simpler way. Anyone? Set inbuilt function of network X. We can use network X inbuilt function, but we do not know the edges. Nah, we have to first create edges. Network X will not exactly know. We have to create list of tuples. Great. We can use list of tuples. We can use list of list, but to keep it simple, if people don't know tuples. So tuple is a data structure in Python which defines a relationship that remains consistent, that cannot be changed. So yeah, we know like an edge contains only two nodes, so we can use tuples. So let me connect these edges, okay? So I will create a list of tuples. A to B, A to B, okay? B to C, C to D, D to E, E to A. Is it correct? Since we are connecting them linearly, we are not making circles. This is incorrect, right? We cannot go back from E to A. Great. So we have nodes and edges. So how do we create a graph? Okay, I don't know. I don't know how to create a graph. Let me create a graph. So I will type network X create a graph. Simple. Tutorial is there. Network X provides the best tutorial about its library. Okay. It is clearly saying you can use this thing, import network X, create a graph. So I will just copy it. I'm not thinking anything. I'm just copying it here. I have created a graph. Okay. So what is G? Let me print it. Let me print it. So it is saying, let me add print here. Just to a graph with zero nodes and zero edges. Obviously, we haven't added any nodes. We haven't added any edges. Okay. So it is saying just add node. Let me add node. I have added one node here. Okay. Now let me print graph. One node and zero edges. Okay. I will add this node again. Let's see if the edges come up automatically or not. Two nodes and zero edges. So what is this doing? We keep on adding nodes. Nodes are there in space. In some space they are embedded, but they are not joined. So we need to join them. Okay. We need to join them. How do we join them? This tutorial will show us. Okay. This will show us. Somehow it will show us. Okay. Let me add this edge. It is saying add edge between 1 and 2. I have added 1 and 2. Now let me print. Two nodes, one edges. Correct. Great. So as you can see, we are doing some redundancy here. We are first adding node 1, then adding node 2, and again we are passing 1 and 2. What happens if we directly add just edge? Will it automatically take up the nodes because it is not taking up edges here? Let me check. I will create another graph here, some G1, and I add edge here. Sorry, G1. Great. This thing and this thing is same. We didn't have to go through this stuff. We didn't have to add. We don't have to add nodes explicitly. Nodes will automatically get picked up when you add edge. Great. Any doubts till now? Great. If you have any doubt, just raise your hand, ping, whatever. I'll get a beep sound here. I will come up to discuss the doubts. This is very simple stuff. Okay. This I will discuss. I'm just checking what do we need to discuss. Okay. Yeah. So, okay. So I tried last time adding nodes like this. So we cannot add it like this. We cannot just run, say, for node in node list. Okay. If I write some code like this, there's so that means there will be no need of adding nodes ever. Yes, that is what I mentioned. Malini, you can switch off your camera. Malini, yeah, great. So, there's no need to add edges nodes explicitly because they are get picked up by when you add edges. Okay, so that's a different thing. Let's see, do we need to add nodes like this only? If this is the case, then the time complexity is very high. Okay, so if I pick up this variable for node in nodes, print node. First, let me print the node. Yeah, we got nodes. Okay. Let me create another graph first. This is a graph G2 dot add node. Okay. Nodes are added. Print G2. 5 nodes and 0 edges. Obviously, it's 5 nodes. We have A, B, C, D. 0 edges because we have not passed edges. These are the edges. This edge list has not been passed. Great. So what happens when you have this node number, say, when nodes are in millions? This for loop will run a million times. So, solution. What is the solution? Obviously, NetworkX provides a solution. That is, I create another graph, okay? I can simply G3 dot add nodes from, okay? We are adding nodes from list. So I will pass this command here and I will write this thing. G3, let's say G3. Oh, just a suggestion, guys, don't print it like this. Just write print to see what's exact. Uh, this basically this print when you run this print operation on this G3 object. Okay, so this is function overriding happening here, which is printing a print function existing inside this graph library, this graph class that prints the nodes and edges. Very high level stuff, but use this directly. Okay. So this has also done the same job. This has also done the same job. So we will use this when we have huge number of nodes. And anyways, like I suggest you use this only because this is not feasible. If you want to apply some case, like say if node is double equals to E, then continue. If you want to leave out some nodes, if you want to pass some condition, then you can use this. But otherwise, directly you can read that, read this file, using read lines. You will get edge list. You can create node list. I will show you how to add edge list as well. You can directly add nodes like this. Okay. So nodes are added. Where's the edge? Where are the edges? There are no edges. 0 edges. It's not a graph. It's basically some nodes in space. They're not connected. You can also add node attributes as well. So say your node 4 has color red. Okay. Your node 5 has color green. So you can also add these nodes attributes. You can experiment these things, but let me first cover the basics. There are a lot of other stuff possible. Literally, you can just go on scrolling here to this thing, throwing everything. Everything is there. And like by next class, I expect you to at least finish till this thing, till accessing edges and neighbors, because we have completed this in week 1, that ego network part. So I would suggest you to complete this part here till here. Experiment it, run the code, whatever doubts you have, we will discuss in next weekend revision class or what doubt class. Okay. So great. We have added these edges here. Oh, sorry, nodes here. How to add edges? How do we add them? We create another graph. Let me show you. G3, network X, G4, make this G4. I'm changing this function to add edges from. And these edges are in variable edges. Okay. Let me pass this thing here. Sorry, G4. See, we have got 5 nodes, 4 edges. Okay. Now, this is the statistic you can see for a graph. But what if you want to visualize? what nodes are there in a graph, what edges are there in a graph. Okay, so let me show how to see what nodes and edges exist in a graph. Hmm? Great. This G3, let's pull this G3 graph first, okay? So this G3 graph for graph G3, print G3 dot nodes. Okay, we got these nodes for G3. And let me print edges as well. Empty list. Why empty list? Because it has zero edges. Now let's run it for graph G4. G4, G4. See, this G3 is empty, but in G4 we have these 5 nodes and these 4 edges, which we passed here, which we passed in this variable. Okay. This is the basic. This is the basic how to use network X. Is network X simplicity running a loop? No, no, no. Yeah, Shikha, actually it's not a loop. It's a lambda function. If you visit the network X library, it's very like I'm not going into the depth of code. So that lambda function does the job for us by broadcasting it over the list. Okay. If you can go visit this source code, you can also see the source code from here. If you go to reference, okay, you go to graph, and you find some code. Just find some code. There's a GitHub reference here. They put it. I will show you later on. First, let me finish this. Okay. Yeah. So we have added edges. We can clear the graph as well. How do we clear? What do we mean by clear? We want to clear G3. We want to clear whatever data is present in G3. We want to start fresh. Okay. Now if I print G3, it will be 0 nodes and 0 edges. See, 0 nodes and 0 edges. Okay. See, this person, this code is what is doing. It's adding slowly, slowly. So this is showing you how you can do it. But whenever we have data, we have in the form of list. We can simply do this stuff here. This stuff. It solves the purpose. Okay. So how do we count number of nodes? You can print the number of nodes. How do we count number of nodes? Number of nodes of say G4. It has 5 nodes. Great. We've also seen this thing. Okay. You can use this as well. So if I just write say G4 dot number of nodes. Okay. Sorry. G4 dot nodes. It will give me some this node view. Okay. So what this node view is an object that is rendered. This nodes is a node view object. Okay. We want to convert it to list. Since we want to use it later on for loops and stuff. So you can do this. You can also do this. You can also do this. There are many possibilities. That's why I'm saying visit this tutorial. Okay. You will get to know a lot of things. Okay, great. This nodes edges is done. Everything is done. What is this ADJ1? ADJ1 is adjacency. What is the adjacent node to 1? Let us run it. If I put it for G4, it will give me an error. Because the G4 graph has no node. Wait a second. How can not add? Sorry, let me see the question. Apply on the list. So it does like apply on the list. Sriram, I didn't get your question. Is it a question or? Hello, Sriram, can you unmute? Related to previous. Okay, okay, okay. Yeah, it does apply on the list. There are many possible ways to do that. And the library, if you see it, I will show you. I will show you. how it adds later on. Wait a second. Um, where were we? Okay. So this graph G4 has no node named 1. That's why it is giving me error. So let me check node B. You can see there was an edge named A to C, A to B and B to C. So the neighbors of B are A and C. Now if I do this thing, the neighbors of A are B only because A is the starting node. Okay, so that's how this you can use this ad, this adjacency object to find out the neighbors of a node. Okay, then there is another function degree. You might have studied degree of a graph. Okay, so whatever we are doing right now, this is an undirected graph. Okay, this is not a directed graph. The edge is not pointing in the direction; it's just connected. So whenever I search for the degree of a node, so if I check the degree of node A, why did it happen? Sorry, G4. So degree of node A is 1 because it is connected to node B. Only one edge exists. Okay. And if I check degree of node B, its degree is 2 because it's connected to A and C. Okay. Uh, what is this? Okay. I'm going to specify to report the adjacent degree from subset. Okay. So this is some graph which they have added here. 2 comma m this thing. That's irrelevant for now. Okay. Let's you can also view degrees of multiple nodes at once. Like degree of 2 is 1, degree of 3 is 2. Let's try this as well. Great function. What we're doing is we are passing this as instead of an object, we are passing this as instead of using this as an object, you are creating this as function, and we are passing the edge list inside it. Sorry, node list. So we want to see the degree of node B and A. So degree of node B is 2, degree of node A is 1. E, let's check node E as well. 2, 1, 1. Great. Node E is the last node, that's why its degree is 1. Removing elements from graph. These are simple functions. I don't want to remove it because we have already created a beautiful graph. We want to experiment a lot of things, but still let me show you, say from this, say G2 is there, okay? G2, let me print G2, what was G2? G2 was a graph with 5 nodes and 0 edges, okay. So let's remove nodes from, say A3, sorry, node B. Let's remove node B. We remove node B from this graph, okay? Now let's print it. It has 4 nodes and 0 edges. Great. Now what happens if we remove a node from a graph which has edges? Let's do it for graph G4. And now let's print graph G4. Sorry, G4. So it has 4 nodes and 2 edges. What 2 edges are there? Let's print the edges. Print G4 dot edges. CD and DE. Why? Because A to B is gone, B to C is gone. So only 2 edges are present. Just the nodes are present, but the edges are not present. Only 2 edges are present. Okay. So that's how you use this function to remove nodes. You can also remove edges as well. You can directly remove edge. Let's try it. Let's try to remove edges from G4. I want to remove this edge C comma D. C comma D. Print G4. Only one edge is remaining, D comma E. But does it mean we also remove the nodes? Let's print G4. Okay, it has one edge, this edge, and four nodes. Four nodes, why? Because we removed node B, so it has now four nodes and one edge. Great. Let me see one, two more things. Okay, so yeah, till we have got till here. Graph constructors, okay, yeah. So what is a graph constructor? Current light now, what we did here was you have a graph, great. You have a graph here. This is a graph 1 comma 2. This is just an edge, an empty graph. Now, what you do is you apply a digraph. Digraph is directed graph. Okay, so you have an edge from 1 to 2. Now, when you apply digraph, what's happening is it's not you haven't given any direction. So what this will do is when an undirected edge is present, Vigila, please turn off your camera. So when an edge is present between two graphs, that undirected edge, so what happens is it creates, because it doesn't know the directed graph doesn't know which direction to point to. So it creates edges in both directions. Great. Let me create another graph and show you. So we create a graph G5 is equal to nx dot graph G5 dot add edges from edges. Great. Now I convert this undirected graph to directed graph. Let me print the edges, okay? We have A, B, B, C, C, D, D, E. Let's convert this to a directed graph and let's see. See, A to B edge was there, but we didn't know the direction. So directed graph created edges in both directions, A to B and B to A. Then B to C, C to B, C to D, D to C, D to E, E to D. It has created edges in both the directions. So this function basically converted a directed graph to directed graph, but we don't use it in regular basis because what we want to do is we want to create a directed graph explicitly. We want to create the directed graph as per our requirements. Okay. So let me create a directed graph from this given edge list. Okay. And then I will show you how this thing works. So let me create a directed graph named G6. So G6 is a directed graph. This graph function, okay, this digraph function can be used to convert a undirected graph to directed. It can be used independently to create a directed graph and then put the edges inside it. So I created this digraph, okay. Now let me put add edges from G6. My bad. Edges. Let me create it again. Shit. G6 dot print G6. So it is a digraph with 5 nodes and 4 edges. 4 edges, why 4 edges? Why not? There's 8 edges. You can count the 8 edges here. You can count, right? 8 edges are there. Oh shit. Sorry. I got disconnected. Sorry. Hello? Sorry. I got disconnected. Am I audible? I will share the screen. I'm share the screen. Sorry. So visible, screen visible. Great. So when we create, when we pass this, this is an undirected graph. It has edges which are not in the form of list now. They are inside the graph and they are in the form of graph. Okay, so they are not in the form of list. So in the graph, when we convert it to directed graph, it does not know which direction to point to. But when we have the list, so the list is intuitively in a directed way. So this is a source node. So see, uh, list is intuitively a direct edge list. How? A comma B means A to B, where A is the source node and B is the destination node. So whenever we pass this edge list here directly, this intuition applies directly in this directed graph. Okay, it takes the edges in the form of directed edges only, and it converts the graph. So let me print the edges. Print g6 dot edges. You can see simple four, five edges, whatever were there, four edges in directed direction. Okay, so that's why I told you. Why do we need? That's why I taught you this thing. The need to read the file. Okay, so if you have a text file, say in this format where you have a comma b, b comma c, c comma d, d comma d comma e. So this is basically an edge list. You can read this file directly in the form of list. You can split it on comma. You can get the source node, destination node. You can create tuples directly. Okay. And then you can just apply it inside this thing directly. Okay. It will create a directed graph. You can also create a directed graph, whatever we have seen. So yeah, that's all about how to use these libraries, these functions to create graphs, and how to use basic txt files to directly import graphs into this network X modules. Okay, so what to use as node and edges? What do we use? What are the posts? You got a question? Sorry. Ah. So nodes can be anything. We have, you can name a node. Okay, you have an entity. You can take an entity. It has some k properties, k definable properties. Okay, but you can name it. You can name the entity, say alpha. So you can create a node alpha, and you can pass the properties here. Okay, you can pass the properties like this. This is a different thing. I'll show you. I will also show this thing here. Okay, you can directly pass the properties. There are multiple ways. That's as we saw here, na? Where's that? This thing. So the node 4 has the color red, node 5 has color green. But what about edges? I add node alpha and beta. I want to pass the property. I want to create an edge between alpha and beta. I want to name alpha is the father of beta. So this edge relationship needs to be put inside the graph. Great. You're getting the point now? So let's add this edge relationship inside the graph. And let's see. Sorry. Node relationship is easier. Like it's very easy to comprehend. But what about edge relationship? Let's see. So I will create a graph G7 is equal to simply this graph. Okay. Sorry. Syntax error. This is one edge. You can see now. This is 1 comma 2 comma the property of this edge. Okay. Let's add another edge as well here. 1 comma 3, the color should be purple. Sorry, let's rename it. G7 dot add edges from edge. Let's hope it does not give any error. It's not given any error. Let me print G7. So G7 has three nodes and two edges, correct? But these edges have some properties as well. Hospital, you know the hospital thing. So hospital A, patient A, you can these patients have some properties, but what about the properties of edges? How are the hospitals are connected? They're in the same city, they are of the same franchisee hospitals. Say they are Max Hospital is there, uh, Ames and Max are connected. So how do you define the edge relationship? This edge relationship matters a lot. So that's how you define it. Now let's see what edge relationship exists. Okay, let me print. So G7 dot edges. Let me print edges. Edge view is giving me these are the edges. Okay, I want to see the property of edge. How do we see the property of edge? Can we see? We can. So let me see what property. What is the property of edge that is connect the what is the property of edges that is connected to those are connected to node 1. Okay, so J7 dot adjacent node 1. So node 1 has node 2 connected to it, whose color is yellow, this edge. Node 3 is there, whose color is purple. So we are getting a neighborhood graph of this node, okay? If I want to visualize, the property between 1 and 3, sorry, my bad, wrong thing. See, 1 and 3, the color is purple. Any doubts till now? Great. Anyone, if you have any like the slightest silliest doubt, just ping. Okay? No one is judging you here. Can we visually? Great, huh? We can. Actually, like since we will be having another week to discuss this stuff, we will discuss how to visualize graph, how to visualize. In fact, there's a chapter. There's in 1 week you will see what visual representations of graphs are possible. Say you have 1 million, 2 million nodes, you cannot visualize nodes. Then you have to see clusters inside what is the possible cluster inside this thing. So you have to visualize communities inside graphs. So we will discuss all that in upcoming weeks. I'm going slow because most of you are new to this stuff, this network X, this graph theory. So that's why I'm going very slow. Okay, and by next week we will be moving a bit fast. If nodes are automatically getting from edge, there is no need for node function. There is always a need. I mean, you cannot just get rid of a function because there might be a case you want to add graph. You want to add nodes first, and then you want to perform some computing, and based on that computing, you want to create edges between them. Say I have created 10 hospitals. Okay, Max Hospital thing. Just consider that case. I know there are 10 hospitals inside Delhi, so I will put those nodes inside that. But I haven't created any connections. But in coming future, okay, I want to connect. I want to say, yeah, this hospital, this is connected. So I will connect them instantaneously at that moment. But that doesn't mean the hospital was not there. It was there. It was a part of graph. It was a part of network, but is what there was no graph between, no graph connections between them. Okay, so that's why this is the need. Right? Basics you can see like whatever I'm doing here, I'm just showing. This does not represent the real world scenario where you'll be using those functions. This node function is there, and whatever functions are there. Okay, so these things will come up later on in the course. Okay, just wait, sit tight. So you can see now, they have added edge 1 comma 3. They can add color as well. They can add color. They can change the color as well. So you can do a lot of stuff. Let us try this thing. Nice and interesting. So in G7, I want to add an edge between 1 comma 4, and I want to color it blue. Great. So how do you access them? So you pass like this double type of thing in double double indexing. When you pass g of 1, you will get 1, 2, and 3. When you pass g and 1 of 4, you get this edge. If you pass this color, you can directly add this color here. If I want to add the color, I've added the color. Sorry. Eh? Add edge. Acha, sorry, my bad. G7. See, something has happened. Hmm. Okay, we can set the attribute if the edge already exists. So I added edge. I'm adding attribute. Oh, sorry, my bad. You guys can correct me when I'm wrong. Let me print G7. So G7 has 4 node and 3 edges. Let me see the edge between 1 and 4. Color is blue. Great. We can change the color as well. Let me change the color. How do we change the color? So a bit of difference you can see. When we want to add a property, we have to call it like this because the property does not exist. But when the property is existing, the color property is already existing, we have to use this notation to access the node, to access the edge. And I will rename it to red and I will now, sorry, G7. So color is red. Let's change the color. Great. Huh. So yeah, this looks very complicated. It looks complicated. Like how many of you can understand what's written here? Just see. Okay. Just raise this like thing which pops up from here. No? Just like it. How many of you do not understand this thing? Then I will explain it. Okay. Okay, I will explain it. Don't worry. Let me copy it. Let's go step by step. Okay. So what's it doing is it is creating a graph first. Then it is adding weighted edges. Now, what are weighted edges? You have studied in week 1. You might have seen weighted edges are those edges which carry some weight or importance. So, say you want to connect to hospitals. Let's go back to that example again. So, aims and max are very nearby. So you connect them and you get that edge is connected. But how would a person know, like, what is the probability that they are connected? How what is the feasibility of going from one hospital to another? So we can basically say the distance between max and AIMS is 1 kilometer, and say max and Fortis is 2 kilometers. Okay, so we want to provide that edge weight. So we will create some sort of inverse relationship. Say 1 divided by 1 kilometer is 1, and 1 divided by 2 kilometer is 0.5. So between max and AIMS, its edge weight is 1, and between max and Fortis is 0.5. So this means the edge relationship between max and AIMS is very strong because they are closer, and Fortis it's very weak because they are far. So that's how you can create edge relationships. So say this 1 comma 2 edge is there, their edge weight is this much. 1 comma 3 is there, their edge weight is much higher. 2 comma 4 edge weight is above 1. It can be above 1. Like our calculation metric was to keep it such that it is comparable. It's something like probabilistic. But here we can make edge weight anything. So we create, okay, we create these edges. Done. These two lines sorted. Now what does this adjacency thing do? This adjacency thing gives us neighbors. So it will give me for 1, neighbors are 2 and 3. For 2, neighbor is 4. For 3, neighbor is 4. For 3, neighbor is 1 as well. Okay, for 4, neighbor is 2. For 4, neighbor is 3. So it will give me something like this. Let me show you. Let me print and show you. Let me carry these two lines above. Sorry, FG dot adjacency. Say, for node 1, we have node 2, 3. For node 2, we have 1. Okay, 4. For 3, we have 1, 4, blah, blah, blah. Okay, so when we run a loop on that, so here n means source node, or for what node we are doing it, for what node we are finding its neighbors. So we will name it ego node. We have studied na ego alters. We have studied, right? Yes or no, guys? Respond. Great. So n is the ego node, and this is NBR's. Clearly shows their neighbors. Okay. NEIGHBOURS neighbors. They are neighbors of this node. And for inside neighbors, they have some attributes. What is the attribute? Their edge weight. Correct? Print it. FG dot adjacence. Okay. Print it. See. Inside that we have weight. Weight of this thing. They have what they have done is they have moved it to this variable. If the weight is less than 0.5, it's written like this, it's confusing, like write it like this. Then print node, print the neighbor, and print weight up to 3 decimal places. Let's print it. See, 1 comma 2, 2 comma 1 is also there because we are going it in this way. Na? For each node, we are finding neighbors. So for 1, the node was 2, neighbor was 2. For 2, the neighbor was 1. So see, that's why they are duplicated. If you take directed graph, okay, now let's do it for directed graph. Let's see what happens. Okay, I don't know. I haven't done it. I don't know. Let's experiment. That's how you're gonna learn. Just experiment. Okay, print it. See, this thing was very big. Now it's reduced. Why? Because in directed graph, the neighborhood relationship exists from source node to the destination node. It does not exist in opposite direction. Like it's printed here. Now it won't print it like this here. See. Uh, See, 1 comma 2 3 comma 4. It ran again. 1 comma 2 3 comma 4. Sorted. So that is the difference between directed graph and undirected graph. Look very difficult, right? But we recorded it. Any doubts till now? Great. And other people also please respond. Only 2 3 people are responding. We have 33 people right now. Okay, let's continue. Hmm. This is also doing the same thing. See, U comma V means first node, source node, destination node, their weight. They extract this data from edge list, then this weight, if the weight is less than. This is just another representation of this thing. Okay, nothing difficult. If you run it, try this thing. Okay, try this thing yourselves. ये क्या हुआ? Sorry guys, network issue. Am I audible? Great. Sorry. Um, yeah. So as I was saying, this is very simple. This is very simple. I want you guys to try it. This thing. Okay. I will share. First of all, do one thing. Now I'm sharing this link directly in this message. Copy it. I will share it in this conversation Google Groups as well. But for now, just copy it here. Okay. Try this thing yourselves. Not try it later on. So see, we can also add attributes to graphs and nodes, and this we will discuss next week when you guys try it first. I want to see you guys have tried something. I want to discuss it with you. I want to discuss from here till here. Okay. Drawing graphs I will discuss, but see, from adding attributes to graphs till analyzing graphs, you guys need to come up, you guys need to experiment yourselves. Got it? Say yes, no, anything, please. Cool. So from here, from this thing, adding attributes to graphs till analyzing graphs. Experiment. Okay. Drawing graphs, I will teach you, but then again go back, do this thing because it is very diverse. I can create infinite representations of a graph using infinite parameters which are existing here. Infinite, like I don't know exact number, that's why I'm saying infinite. Although infinite is not possible, but there are many like in unlimited options possible. So we will discuss this thing, but I would suggest you try till this point, till this analyzing graphs. Okay. Sorry, extremely sorry. Shit, extremely sorry. Ah, sorry. So from here, from adding attributes to graph and nodes, okay, from adding attributes till analyzing graphs. Don't go for drawing graphs and this stuff. This is, you can try if you want. Like I'm not stopping you, but try it. Try this thing. This is very important. Try till analyzing graph. Okay. So this is all about how. What is the date today? 28th July. Cool. I will share this notebook as it is. I will make some changes and I'll share it. But for now, this is the thing you have to revise it. Revise it. I've done a lot of stuff from basic. Okay, revise it. It looks small, but we experimented a lot of things. So let me take the doubts. Do you have any doubts? Anything you want to suggest? Anything you want to discuss? 4 or 5 minutes, you can. Thanks a lot, Shika. Anyone else? Anything? Please don't drop now. Like wait for 2 3 minutes. Let's listen to the doubts of others. Anything basic? Anything? Any suggestions you want to give? You want the way I'm teaching you? You want to change that? You want some changes in that? Anything? You can unmute yourself. You can speak. Raise your hand, unmute. You can speak. Okay. Don't need to type long messages. No suggestions. I'm not that much a good teacher, I think. Would if I could personal email from you on research interests. Email IDs are visible here, no? Yeah, you can pick it from. I will email you. I will email you. Don't worry. I will email you by tomorrow. By day after tomorrow, I will certainly email you. But I have some commitments. Like I'm busy. Very internet sucks. Hello? Sorry guys, that's a lot of internet problems in IIT Delhi. Still, I'm sharing my screen. I don't think so. We will. So if anybody types something, it's gone. Please speak. Whatever doubts you have, please. Google Collab. I will share it this thing now. This Google Groups. Please join it. You can join it from here. This QA thing in source. This course page. It will open it and it will open here. I will email you guys here. Okay. Everything will be shared to you here. It will also be uploaded on an Excel sheet. Okay. We have to upload it mandatorily. Everything will be shared. No problem on that. Any doubts? Anything you guys want to discuss? Last 1 minute, guys. If you have any doubts, please please anything, any silly thing, whatever you want. When we will drop off, we will end this meeting and we will join next week, same time, 6 to 8. Complete the assignment. You can do it by deadline. Okay, don't worry about that. After the deadline, I will discuss. Because the thing is, if I start discussing the previous year's assignment as well, you will find some of the questions similar. So that will be unfair again. So that's why I want the deadline to be over. Okay. So by then we'll start discussing. I don't know why they keep 2 weeks deadline. They should be. I'm not sure. Like I'm not commenting on that. Once you have finished the content, the assignment should be done in that week itself. Anyways, we have 2 weeks, like 1 week today, and next week we will discuss Network X. A lot of things to learn. And if something's some in future there's a scenario, uh, do we have to join? Please join. Like it's good. It will be good for me to be connect to remain connected to you guys. And you guys can also ask anything there, silly questions, anything, whatever you want. I will reply in 24 hours. 100% sure, certainly. So yeah, if in future also we get another week like this where we cannot discuss the assignment, then what we can do is we can start with uh, this thing, what we call torch machine learning, PyTorch geometric. Okay, PyTorch geometric session will be a bit advanced if you don't know deep learning, but I will keep it simple. I will keep it simple such that you guys, whatever we did in Network X today, na, we will do it in PyTorch geometric. Python geometric, we can also create graphs there. We can also add edges there. We can do everything there. Okay, just a different library. Like NumPy is there in Python. So whatever you do, you can do in NumPy, you can do in PyTorch, you can do in TensorFlow. So that way we will do it. Okay. Then you can compare. You can compare the differences between this network X and that torch geometric. Okay. So yeah, that's all from my end, guys. If you have any doubts, I'm taking it for final 1 minute. After that, we'll be ending it. Okay. And we'll be ending today's meet. Anything, guys, please. Thanks, guys. See you next week. Okay. Bye bye. Take care.